Hi, everyone. I mean, all 8 of you. If possible, could we all sit like in one maybe area? Like that way, I'm okay to throw away all the slides and just answer questions if that works also. Ken's got really nice slides though.
Mine's prettier.
He had a marketing person do his. And an engineer.
And an engineer. I got a team. So, well, I guess we could start. I mean, I know we're standing between you guys and dinner, so we can make it as...
Clearly, you guys didn't get the memo. You could go straight to drinks.
So why don't you fast forward to your deck?
Cool. So yeah, today we're gonna, I think the point of our talk is we're here to talk about sort of some of our experiences scaling our own businesses. Ken's business is largely focused on the data analytics backend side. My business, while having sort of a fairly ripe sort of backend, is largely a consumer facing, so it has more of a front end to it. Our decks are in sort of weird order, so I'm gonna skip through. Can you see all of Ken's slides? There's no money shot in here. None for you, sorry. So my company is called Chute, and we're in the business of making businesses operate in a more visual manner. The best analog I could give you for what we do is sort of, you can imagine us sort of like a Heroku, but for specifically tailored around media-centric apps. So apps that deal with photo and video, integrating users, metadata, et cetera, authentication. What I will talk about, just to give you some facts about the company though, there's about 40 of us, about half engineering. We're Y Combinator backed, and Turner Media Camp. We've raised about $10 million or so. We work with about 70 or 80 enterprise customers now, and we manage a fairly decent amount of data, growing pretty regularly. The 4 topics that I thought that would be most interesting to talk about are sort of the challenges that we've sort of had to overcome, I think, in the transition to becoming sort of a DevOps-oriented shop as opposed to being sort of the fly by the seat of your pants, deploy a box and hope it works type of company, are really sort of data and sort of the challenges of dealing with that at scale. The increased role of sort of automation, and then sort of handling and dealing and succeeding with uptime. And then ultimately, like, how do we monitor our applications? I have some stats in here. I just want to grab them out of here. Data is actually a really, really difficult thing to sort of manage. And I think our business made the mistake of not sort of giving enough attention early on to how we wanted to do, to use data and sort of manage data. And I think that it is something worth sort of dealing with in an upfront manner to make sure that you sort of account for how it will be used, because it is easier to expand than to have to scale like while under load. We have now recently moved to sort of using, we are using like sort of Hadoop with Scoop in the middle, doing a lot of log shipping to sort of move now our raw data out of basically our varnish logs, as well as now our event logging systems, to push data back into ultimately a Redis cluster, which caches and queues that data, and then ultimately we push it into Elasticsearch, which then makes it accessible to a number of our different services. Let me just get some numbers out here for you. So just relative to give you some scaling of where we are right now, we've got about a terabyte of Postgres data, sort of that's online. That was actually quite a bit of a challenge. I think one of the biggest challenges we had this year was sort of we moved first from MySQL, last year we moved from MySQL to Postgres, and then I'm moving from Postgres currently to sharded Postgres. We ran into a number of very specific instances, for example, using like SSDs with different configurations of like Ubuntu with the AMIs, sort of, and different hardware combinations. We actually kept having boxes fail. We were using a Wally. I'm not sure if you guys have experienced that, but we were constantly having to switch to our slave, and then it was dying. And then, of course, with the load, that sort of like became this impossible task. We eventually gave up and went back to EBS-backed volumes as part of the process. We have definitely discovered, that the more and more automation we can put in place, the better it is for the whole organization. just relative to sort of the accountability, helping developers know how to succeed, et cetera. Our business also is predicated on a lot of real-time image processing, video transcoding, et cetera. We currently have about 15 terabytes of assets stored in S3. Those, generally speaking, don't include the originals. So we are still redirecting. One of the services we offer is a redirect to say the original. So if a user links in an Instagram file, the original file will be served from Instagram, but all the derivatives will be served from us. And so we do that the transformation in real time, and then serve those. So that 15 gigs is actually just from the resized versions for the most part. Of that, just in the last month, 1.3 terabytes was added. Our Mongo is also another 14 gigabyte instance sitting in the front. And there's a really interesting, there's a lot of problems that come up that we've seen sort of with just dealing with Mongo data, and like, for example, with replica sets. Not sure if everyone's aware, but when you have a replica set, if you haven't pre-configured it, you have to shut down your Mongo instance basically to get that to work. A really big, annoying mistake sort of in the middle of sort of trying to move to sort of a replicated Mongo instance. So we definitely think, my advice there is to make sure that an ounce of prevention does go a long way, sort of understanding what you think you're going to be at, making sure your instances are sized right. That sort of all helps you deal with data issues, because you end up spending as much time, actually significantly more time, I would say, dealing with just making sure that you have like great and clean data after the fact because you didn't plan ahead, right? And so sometimes that little bit of prevention can go a long way. We also offer like voting, so we have another 85 gigs of data in Mongo just on votes on photos within our system. So that's sort of some of the stuff that we've been seeing like on the data front. I think like data is just like I'm going to defer to Ken because he's probably got a lot more on the data pieces of this. Moving forward, though, I think this year sort of was the year that we sort of became a more DevOps-centric shop. And so if you go back to the beginning of the year, we were probably on, I think, like 40 instances at the beginning of the year. We're up to 100 now. None of those instances were managed by Chef at the beginning of the year, and so it was a slow process to sort of move your way through. Unfortunately, there is no way to say, make this instance my recipe, and then just have that become sort of the way it works. And so there's a lot of trial and error that goes into that. Fortunately, there are tons of recipes that also can help quite a bit, and so you should leverage the community, I think, if you're trying to move yourself through that process. Let me just get to my next sheet there. The good thing about sort of DevOps, though, is that it allows you to treat servers more like code, and I think that that's a really powerful concept. It also makes it easier for more people in your team, like your engineering team who may not be entirely well-versed in sort of the ops side of thing, to actually still be able to do the experimentation that they need to do. I think now we're at about 80% of our boxes are actually properly managed by Chef. Our goal is to get to 100% at some point early next year. I think the challenge is that there are a lot of one-off boxes, and sort of they require just as much in an investment to get there. I believe like we spent probably close to 100 hours already just on sort of like recipe tuning to sort of get everything right to be able to deploy the way that we're doing. So it's a pretty significant investment from how oftentimes you start off in a very lightweight manner and sort of throw things together. Keeping a log of those things would be really powerful, and sort of that's a great thing to sort of start keeping track of early on if you know you're not doing it sort of the right way. Another thing that automation has helped us deal with is sort of like log rotation. A lot of the other tasks that like actually go that slip through quickly, and so boxes fill up sometimes because they run out of space. Getting things to an automated environment sort of make sure that as you learn lessons about things that will cause you issues, you sort of automate and build those into your recipes, and that's taken care of over time. Uptime. This has been, a challenge. I like telling our customers that, we sell SLAs to our customers, and every 9 that someone asks for almost doubles the cost of our infrastructure, because it actually means adding every layer of redundancy is actually quite expensive, right? And so uptime is a really important thing for our business, and I imagine for all of your businesses. we finally were able to like achieve 100% uptime across sort of all of our environments this year finally. I think that was definitely the result of automating more of the problems, instrumenting more of our systems to sort of understand what was going on inside of them. One of the best hints I can give you here, though, about uptime is like the single points of failure. So, using databases that actually scale horizontally is a huge win relative to sort of having the big clunky box. We had a lot of problems like with our Postgres instance. It's taken us basically the entirety of this year to plan for our sharding, to move our Postgres sort of across multiple boxes. And actually, we won't even move it across multiple boxes, just doing logical shards on the box as opposed to actually physically breaking it up. That planning actually, though, is significantly harder now. But, again, there's always this balancing act between sort of like pre-optimization, right, versus sort of like preventative measures, right? And I think we're sort of trying to figure out not to do too much pre-optimization, but also to think about what that next step is to make sure that you're not sort of just shooting yourself in the foot. It's probably impossible to know how much growth you're going to have. Some things are very spiky, some things grow very regularly. And so if you know that spikiness is sort of a natural part of like the business that you may be in, then you should plan around the idea that you may have massive growth that's unexpected. And so everyone says it's a good problem. It doesn't feel like one when it's happening to you. I don't relish sort of being in that spot. The more applications that we can write that sort of like write, fire, forget, right, are great, right? But the only way that works is sort of to have like great information coming out of those applications, so you know that you're actually building something that's worth sort of, that you don't have to actually pay attention to all the time. Today, I think we have a little bit more of that peace of mind, but the reality is every day it feels scary, right? Like it feels like, how do you know we didn't miss something? How do you know when you have anonymous assets sort of out there? And I think like when you think about it from an application point of view, uptime is something that I think we actually try and hide from our customers, right? Like we do things in our application layer that actually are meant to sort of mask. And so the real question is, when you build those masking techniques, when you build those things to help you prevent sort of the user from having to see how much downtime or any issues that may happen, how much else are you hiding in the process, right? We've had examples, a great example from us is we built a technique to hide broken images from like the front end. And then one of the things we realized is like, well, all of a sudden now we don't know, no one's telling us that there's broken images anymore. And so then you couldn't tell when there was a problem to look into, like if there's a certain type of data that was coming in anymore, if it's there. And so again, it requires that as you make that change in the front end in the application layer, that you have exception handling and system level stuff that's actually letting you also catch those errors from the other side to actually try and deal with the problems that are still happening. So the last thing I'll talk about is monitoring. I think the broad point that I'd like to make about monitoring is that scaling an application is sort of like a dance, right? It's systems, it's software at the same time. And as systems people, it's easy to just, you stare at, sort of, processes all day and you look at that and that becomes like your universal metric of whether or not you're succeeding, right? Like if the numbers are where you think they should be, that's okay. But, I think like Warner made the point today that it's like that 99th percentile. It's like what's happening in those edge cases. And so oftentimes it's something happening in the application layer or in the client layer that you may be missing by only looking at one part of the data, right? And so we try and gather data from like all parts of our system. We use Logstash and a lot of other things like that to sort of do log analysis. We use Datadog to actually let us correlate sort of our commits and other activity and events like with actual like specific system measures. And then we use New Relic to do our application monitoring. And then we have another reporting layer in the software and the client side. And so all of the goal of all of these pieces being to sort of bring us to a point where we can see activity across all parts of the system, because even though one may be operating normally, another one may be out of whack, And I like to use the analogy, it's like a blanket, it's like, what's that movie? Dead Poet Society. He says that, it's like a blanket that doesn't fit, right? Like every time you pull it a little bit in one way, something else gets uncovered, right? And so we're constantly battling sort of the opportunity to cover one part, right? And that usually opens up or leaves something else uncovered. And so I think the hard biggest challenge for all of us is sort of now sorting through those opportunities and making sure that as we move this piece, what's the impact on the other pieces? And there's just other parts of the system that are harder to see and harder to test. And so the real energy has to go into finding the parts that are hard to test and then ultimately getting a quick mechanism for resolving issues. I think that's about all I've got, actually. I'm good. Ken's turn. I'll rewind for you.
You can rewind for me.
Yeah. See, he has all the nice charts. By the way, the first draft of my deck was way better than his.
I took a copy of his and made it better.
Here, you can finish rewinding.
Finish rewinding. Okay. All right. Okay, just to give you guys a little bit of context about Euclid, I think Greg focused a little bit more on the end user experience and the front end applications of a high-end website. Euclid's problem is actually a little bit unique. We are focused more on the data acquisition problem. So I'll give you a little bit of context of the problem that we're trying to solve and then the solution which basically took us about 4 years to get here. So I won't imagine that if you have data acquisitions problems today, that you would have kind of followed the same journey we did, because Amazon has changed drastically with the tools and platform over the last 4 years. So what is Euclid? So we're essentially a offline analytics company. So imagine in the e-commerce sites, you have a ton of data coming in. You know everything about what your users are doing. You know which websites they're going to, you know which links they're clicking. We're offering the same type of analytics, but for the brick and mortar businesses. So imagine you going into a mall, you going into a store, you're able to figure out how the users behave in an offline environment. So the way we do that is we use Wi-Fi signals in everybody's smartphones. Everybody's smartphones with the Wi-Fi turned on are essentially communicating with their access points, and they're spraying AWS frames in free space. So what we've done is basically we're essentially partnered with all the access point providers. We build our own hardware, and we basically collect all these AWS frames, and we basically funnel all that data into the Euclid cloud. And then once it gets into our system, we basically process that data and offer the same type of analytics to our customers. And our customers are essentially the high-end enterprise retailers. So a little bit of Euclid's pedigree. We're one of the first pioneers in the space, 4 years old, almost 5. Executive team, we've been featured in the press. We came out stealth a couple of years ago, so we've raised over $25 million. So we've been around for a while. I guess we're considered an old startup at this point. So why are we a data company, right? So we acquire data. We basically are ingesting a fire hose of data. We have our sensors and our partner sensors basically cover over 600 shopping centers, malls, and street locations all across the US, all across Europe and some of the Asia countries. So we collect about over 30 gigabytes of data per day. So it's optimized and it's coming through in a very secure channel. But we process over 50 terabytes of raw data. So we acquire the data, and then our challenge is really to process that data. And then our end users, which is the enterprise retailers, are the consumers of the data. So again, any type of challenges are pretty much the same. Scaling, performance, costs, all the unique those challenges aren't unique. The challenge that's unique for Euclid is really because we have so much data and because we do so much data processing that our recompute costs is fairly high. So imagine we have historical data of over 2 years of specific customers. So we come up with a new algorithm, we come up with a new math model, we come up with a new stat, and we have to go back and retroactively reprocess all 2 years worth of data for maybe one customer or our entire customer base. So we actually need the computation of maybe 10 nodes, and we usually scale sometimes up to 1,000 nodes at a time to redo these computations overnight. Use of AWS, we've started with Amazon on day one 4 years ago. We've basically matured along with the Amazon technology, started with EC2, started with RDS instances, moved on to Elastic MapReduce. We were doing cascading. We moved to Pig. We moved to other types of MapReduce technologies. And in terms of data acquisition, we basically use Beanstalk for the acquisition side. And this year, we basically were in the early developer program with Redshift, and we basically are on Redshift's production environment as of today. The end user piece is really fairly basic. We've aggregated all the content into relational databases, and we just use Heroku to serve our end users. In terms of our architecture, it's fairly generic in the sense that we have Beanstalk, which basically covers our data acquisition. That basically provides the multi-zoning and high availability. Our pipeline processing is essentially, pulling data from S3, sweeping it in, putting it in Redshift, and then processing the data into end user reports. So summary of data acquisition, we try to keep that as simple as possible, and literally it's basically 12 lines of code. We're basically collecting all the data from sensors that are summarizing 802.11 data frames in the access points that you see here today. We're integrated with Cisco, Meraki, Aerohive, all the major Wi-Fi vendors. So when a customer turns on and enables this Euclid on their Wi-Fi system, we're literally basically ingesting this fire hose of data immediately in real time. So Elastic Beanstalk is the way we've scaled. The processes basically are logged onto the EBS instances, and they're swept across on a periodic basis and dumped into S3. This literally is our data acquisition code, 12 lines of code. Just ingest the fire hose and log it. High I/O, be as dumb as possible, and throw the data on disk and use and basically focus on batch processing. We actually are experimenting with Kafka for the real-time processing, but I think some of you guys probably know that Kafka is discontinued. We'll be experimenting with Storm and Kinesis pretty soon. So just to show you some stats, because of this data acquisition architecture, our load and our utilization is extremely low. We can scale for the next 10 years with this architecture. So in terms of processing MapReduce, it's a little bit interesting because we actually have a culture that sort of embraces chaos. We have a pipeline that basically takes our production algorithms, and we basically read the raw data, process it, put it in customer reports, and deliver it to the customer. But we have an R&D and analytics group that basically are constantly experimenting with the real-time data, constantly experimenting with new algorithms, constantly experimenting with new math models, and we have to provide an environment that they can basically run these tests really, really rapidly. And hence, from a pipeline perspective, we have dual purposes. The engineering side, we're just basically take the working algorithms and just scaling it across our terabytes of data. And then our analytics side, which is the end users are Excel users, Tableau users, maybe some Python. They need something that's very SQL friendly. So hence, we have a dual pipeline architecture. One is the S3 processing, and the other one is the Redshift architecture. Both by AWS. So this is one of the reasons we moved to Redshift is because of the SQL limit. We reached our 1 terabyte limit, very quickly, and I think we're able to basically do a lot of the work with Redshift And I think some of the stats you see here, some processes that took 5 hours to do earlier on now takes less than 2 minutes. So Redshift is probably one of the biggest values in terms of speed and innovation for us, because we basically iterate the algorithms very, very rapidly. Monitoring, as Greg mentioned, is extremely important. Our pipeline processing is very, very complex. So let's. Did we just lose it? Huh? Did I just do? I did. It looks fine here. Okay. Okay, thanks. I pushed the wrong button. Sorry. So this is essentially a snapshot of our pipeline. So a lot of dependencies. We use Jenkins to monitor the workflow, but you can imagine like any one of these failures are dependent, create a huge dependency issue. So a lot of these processes need to be restarted if there is a failure. So our monitoring tends to be pretty sophisticated with Jenkins. And I think that the lesson here is that we basically set our customers' expectations that our processing of data has a 24-hour latency. So we always do reports after a day. So if any of these processes actually fail, we actually can recover within hours, and then we can reprocess the data. Lastly, I think the benefits are pretty simple. We focus a lot on apps. We're trying to fail as fast as we can in terms of the value to the users. We don't want to basically have to spend the time and energy to basically create an ops team. We're focused on innovating on the data itself. I think the benefit for us is that we really truly use the elasticity of the AWS system. We basically can scale literally 2 or 3 nodes to 1,000 nodes based upon the amount of processing we need at a given day. And we pay as we go, so very cost effective. Any questions?